Good morning. I'm from the University of Lisbon. I'm a mathematician at the Department of History and Philosophy of Science, and I teach history of games. My games are not exactly your games, so I feel a little bit foreign here. I'm amazed what things you talk about, and I'm curious, so I'll help. I hope to learn something about it. I want to talk today a little bit about games and mathematics, and to stress the point that if you study history of board games, you need to know mathematics, otherwise you don't get it. And I want to give a few examples. Of course, games are part of leisure, and this sophisticated way of having fun with thinking, well, it's old. For instance, Alcuin of York, at the end of 9th century, already proposed some activities that can be identified with games, and that really cannot be understood without mathematics. This is just the crossing, the very well-known puzzle of the crossing, the wolf and the goat and the cabbage and so on. I don't have time to let you enjoy the joke, because I don't have time. Well, the oldest game that we know exactly who invented, 10th century France, Ludus Regularis, was a game invented in the context of the church that forbade the use of dice, and that this priest, Wiebold, invented a game, very complicated game, that uses dice in a context of the church with virtues and things that are allowed. And he made it's a very interesting game. This image is from the exhibition that is in Lisbon at the Museum of Science. Whoever wants to visit, there's a little exhibition on ancient board games. And this game uses dice in a way that is absolutely new, and it's very interesting. And if you don't understand a little bit about probability and that they didn't exactly know much about it, you don't get the game. Look at this die; it's amazing. It's a tetrahedron. Well, I have to rush a little bit because I have lots of slides. Some numbers that are today that show up everywhere in games were born in this game, 21 and 56, for example. That they have to do with dice, then they show up in tarot, and they then show up along the history of games in lots of places. Rhythmomachia is maybe the most striking example. It's a game invented in the 11th century in Germany, and it was the most popular game for 500 years in Europe among the learned people. So it was a fantastic game that died out in a way that we lost memory of the game. You have to dig into libraries to find the records, and for reasons that I can explain some other time. But this game, you see, this is the board. It's two chess boards put together, and then numbers, and then rules, arithmetic, and so on. To understand this game well, because this was a game to be played in the classroom, a game that was invented before the university, and then all the universities used the game as well, and so on. And they produce. You really need to know the mathematics of Boethius, the Roman from the 5th century. And if you don't read his work on arithmetic, you don't understand well the game. That's my point. This is a game I studied well a long time ago. Is referred in Utopia by Thomas More. As you know, Thomas More has an ideal society. They only do smart things, and they play this game. They don't play silly games, but they play this game. Rhythmomachia. Well, there are games of astronomy that are also very scientific without true knowledge of the apparent movement of the planets. You don't get it. You don't understand the game. And the same thing for a similar game on geometry. It's the same thing. You really need to know what is the essence behind the game. This probably you don't know. It's a game invented by George Berkeley, the philosopher, 18th century. He invented a game called Ludus Algebraicus that has a beautiful board. I'll show you in a second. And the game, to understand what is going in his mind, you have to know the algebra by then. Not now, it's by then. because now we know that algebra is a field of mathematics that cannot do what it looked like it could have done if you were in the 18th century when there were big hopes on development of algebra. And so it's very interesting to study what Berkeley wrote about, but it's more important that you really need to know what was algebra by then. Algebra was a field of mathematics that mathematicians believe that if you could write a problem in an algebraic expression, equation, then you would solve it, because algebra sooner or later would eventually solve every problem. It's not true, we learned later, but it was fantastic. Look at the board and tell me it's not beautiful. It's just beautiful, so symmetric, it's really, really beautiful. The game sucks, the game is terrible, absolutely terrible, because he couldn't know enough algebra to know that it's unbalanced. It's not a good game, but okay. Of course, some of you know this game Eggs, that it was a surprise for mathematicians. It was invented in the 40s of past century. It's a very easy game. The rules are one line, but the relations with mathematics, not related to game playing, but related with mathematics, are very surprising. For instance, what we call the theorem of X, the fact that this game has no ties, is equivalent to a deep theorem in topology that you take a few years even to learn the statement of the theorem, let alone the proof. So it's very surprising that an easy thing in this context is logically completely equivalent to a deep result in mathematics. Combinatorial game theory, it's a subset it's a sub-area of combinatorics. Here we have founding fathers in a colloquium. We usually go on recreational mathematics, Guy, Conway, and Berlekamp. It's a set of techniques to study a kind of abstract game, a family of games, that made it possible, for instance, to recognize that this is a traditional game in Ivory Coast called Tuk Tuk, that the locals know how to play perfectly, and so they hustle the foreigners, and they get money from them. And this game is, we know by combinatorial game theory, that it is exactly the same game of the Alain Resnais's movie L'année dernière à Mayambad, a game with matches. It's the same thing as a subtraction game introduced by Luca Pacioli in 15th century. It's played with beans on the table. So looking at these games, they all look different. But knowing the right mathematics, you see they are the same. I know to play well one, I know how to play well all of them. They are all the same thing. So it's absolutely unavoidable. I don't know if you know Conan. Conan was a game described by Francis Drake. It's played in Hawaii. And it's surprising because the rules are completely combinatorial in the mathematical sense. It looks like drafts, but it's not. It has some difference in the rules, and so mathematicians know a lot about this game. It's very difficult and very beautiful, Conan. Of course, classical game theory. Classical game theory is also important to understand games, because games are a kind of a field of strategic thought, which is not only conflict and cooperation and so on that we are used to. So this is an example from the Talmud of strategic thought, is dividing the bankruptcy state of a dead man according to the amounts of money that three different people want from him. And these numbers, they look like there's no pattern here, and however there's a big pattern here, and it took thousands of years to be discovered by mathematicians, game theorists only. Of course, games this kind, you know all about this, of course, and Prisoner's Dilemma. These are paradigms, they show up everywhere. This is a striking example. You know the game of goose. The game of goose, the players don't do anything. They throw a die and they move the little things. So there are no decisions to make. However, the game is fun. And players play the game, even adults, because in my classes I made the experiment. And so a colleague of mine from the computer science department and myself, we cooked up a way of understanding what makes this game fun. And some race games, most of them are not fun. And the game of Goose has a historical characteristic of having been invented to be offered to Philip II. It has a very nice story, but I cannot continue, so I'm so sorry. Maybe next time. Thank you very much.